Welcome to the topic, Symmetrical Optics. We are continuing with more concepts. Today we are discussing types of lenses and their applications. We have several types of lenses here. We have the equiconvex, has two ends, 1 and 2. When you observe it from this side, it appears convex. Observe it from this side, appears convex. So it has two ends which are convex, and it is equi, meaning that the radius R1 equals to radius R2. Plano-concave, from the word plane, so it has a part which is plane and a part which is convex. It has end 1 and 2. If you observe it from end 1, it is flat, and when you observe it from end 2, it is convex in nature. By convex, we have end 1 and end 2. If you observe it from one end, it is convex. Observe it from this end also, it is convex. So it is biconvex, meaning it has two ends which are convex. Bi means two. Here we have R1 not necessarily equal to R2. Convex meniscus or converging meniscus, it has two ends, 1 and 2. 1 and 2. You observe it from this side, it appears to be converging. Observe it from this side, appears to be diverging. Those are all convex lenses. We go to diverging lenses or concave lenses. The first one here is equiconcave, has two ends, 1 and 2. You observe it from this side, it appears to be appears to be a concave lens or diverging. Observe it from this side, it is still concave in nature. So equal, meaning R1 is the same as R2. We go to plano-concave, just as plano-convex was. It has two ends, 1 and 2. Observe it from this side, appears to be concave in nature. Observe it from this side, it is flat. Biconcave, we have end 1 and 2. Observe it from this side, it is concave in nature. Observe it from this side, it is still concave in nature. So it has two, bi means two ends which are concave. R1 here is not necessarily equal to R2. They might be the same, but not necessarily. The last one is diverging meniscus. Just as converging meniscus was, this also has two ends, 1 and 2. Observe it from this side, it appears to be converging. Observe it from this side, it is diverging. We go to application of lenses, and then the first one is photographic cameras. As you can see them in the diagram, they contain lenses inside here. So these lenses can be a combination. In here we can have a combination of both converging and diverging lenses to form a well and clear image. We have also the spectacles or eye lenses. If you look through this lens, you see that the environment is very clear. You can see the trees and the grass clearly. But if you observe from this part, you don't see it clearly. It is faint, meaning that these lenses can be used to correct eye defects like long-sightedness and short-sightedness. We have telescope here. We have several types of telescopes. For example, astronomical telescope. So that is used to observe distant objects like the moon, stars, and galaxies. The way we form a telescope, it is made up of lenses. It may have two converging lenses combined, or it can have several types of lenses. So it can have 3 converging lenses combined. Sometimes you have telescopes which are having converging lens and diverging lenses combined. As you can see in the diagram, the next is a prism binoculars. So it's called a prism binoculars because inside it contains prisms. The lenses are used to focus or to have a clear view of the image that you're observing. These are used basically, sometimes you can go for a sport, maybe goat racing, and then you cannot be able to see clearly, so you use the binoculars. Sometimes they're used by hunters to see a distant animal as they are trying to hunt. Sometimes they're used by military to see distant places and know whether they are secure or the enemy is coming. We have also the front car light lenses. Not all cars have lenses in their lights, but here we have a lens. The lens is to give a clear focus for the light. Next one is door peepholes. So the door peepholes, as you can see here, let's say you are inside the house and then somebody knocks on your door. You want to know clearly who that person is before you open. You peep from this hole and then you can be able to see what is outside. So this contains a lens inside that also gives a clear view of what you want to see. We go to microscopes. So the microscopes, these are so common, like the type that we have here is a type that is used in laboratories. Here we have an electronic circuit. It is having microscopic components like capacitors and diodes, and then you cannot see them clearly with your eyes, so you use a microscope to see the microscopic view of whatever you want to observe. Then this is also commonly used in laboratories for biology to observe the microscopic nature of maybe like a housefly or a frog or a cockroach or even a leaf, so you can clearly see this. So in here, in the eyepiece, there are lenses that help to magnify what you want to see here. We have also the last one is going to be the magnifying glass. The last one but not the least, and it's not that we have exhausted all of them. There are so many other applications of lenses that this is also common in biology labs to be able to see uh, magnified images. You can also play around with this when you focus sunlight and then you put this magnifying glass, you focus it from the sun, so this can be able to concentrate all the heat onto one point. So if we put here a paper, it can be able to burn it. It has a wonderful application.